Alright, so during the first part, syempre tinignan natin ano ba yung definition ng material balance, and then we looked all up to the way up to trying to do process flow diagrams for something as mundane as pagsasaing ng bigas. So now let's look at all the other principles needed to start solving your problems the food engineering way. Isa sa mga mahalagang konsepto ay ang batch and continuous process. In food manufacturing, each sort of piece of equipment can operate under a batch and continuous process. Minsan din yung buong sistema mo is either batch or continuous. Let's illustrate it this way. When you have a batch process, a fixed amount of matter undergoes processing for a fixed amount of time. For example, yung typical na pagbe-bake ninyo ng oven sa bahay, gagawa kayo ng pandesal or cookies, one batch would be kung ilan man yung kasya sa oven nyo at any given time, and then lulutuin nyo siya for a fixed amount of time, let's say 15 minutes per tray or something like that. So usually, ang minimeasure mo ay yung batch size, ilang kilo, ilang piraso, ilang liters ang magagawa mo sa isang batch, and at the same time, how long will a batch take to become a products, no? Gaano katagal yung process. Examples of this, let's say if we mentioned the steam jacketed kettle last time, and if you want to cook ketchup there, one batch will be ano man yung capacity ng kettle mo, and then the length of time to cook that is the batch time. So as well as in baking ng bread, it's also an example of a batch process. On the other hand, yung continuous process na sinasabi natin is outputs are churned out one at a time continuously, or kung by volume siya, dire-diretso parang gripo. Okay? And usually this is measured in terms of output rate in mass volume or pieces per unit time, such as when you are filling ice cream tubs, imagine nyo yung parang soft serve sa mga 7-Eleven except na malaking butas. So that's measured in liters per hour. Or let's say you're gonna wrap pastillas, that's in pieces per minute. In the case of bread, although bread making is a batch process overall from start to finish, meron siyang parts doon na continuous processes, like let's say yung, di ba pag yung dough, gagawin mo siyang individual pieces of pandesal, yung kinakat-cut mo siya. So in a way, medyo continuous yun kasi isa-isa yung paglabas mo ng cut pieces doon, na yung meron kang dough, tapos i-flatten it and then chop, 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 chop mo. How many pieces you can make per minute of those chopped breads are a determinant of yung overall process time mo. Okay? So generally, when you have a long production process, there's usually a combination of batch and continuous processes linked together. And it's a matter of logistically weighing yung rates nila, i-match mo yung size ng isang process to the other para smooth yung operation, kumbaga wala kang bottlenecks in your operation. Alright, so other concepts that we have here, component mass balance. So ano nga ba yung component? In a given problem, whenever you cannot simplify another ingredient or stream, yun na yung component mo. So let's say kanina, your components would be only water and yung bigas component, no? In certain cases, these might be ingredients, like let's say kung meron kang sugar and oil and water, pwedeng yun yung mga components mo. As long as it's the simplest form in the problem, you don't have to subdivide it. If you call it tomato juice, then it's tomato juice. Okay? And so on. So total mass balance is applied to individual components. Hindi yung tinatawag nating component balance, no? Parang tinatali mo, saan ba yung lahat ng water ko napunta? Ito lahat ng inputs ko ng water, ito lahat ng outputs ko. Ganon. So, and then we also have what we call the tie material or tie component. Ito yung isang component or material na hindi nagbabago between component balances, or in lucky cases, between during the whole process. Now, for example, sa pagsasaing natin, if we were to assume halimbawa na yung bigas mo ay hindi nagli-leach out ng starch particles sa water, then yung bigas na pinasok mo 100%, yun din yung bigas na 100% nun natira dun sa washed na bigas and 100% nun napunta dun sa cooked rice. So kumbaga, pag nagko-compute ka, mas madali kasi meron kang pag in terms of systems of equations and unknowns, meron ka na automatic isang equation na mako-correlate mo kasi yung mass nung tie component mo ay same dito sa equation 1 mo at sa equation 2 or something like that. Alright, so let's try doing component balance. So for our component which is water, let's try to account for all water inputs and water outputs. Alright, assuming no accumulation. So we have water 1, yung pinanghugas mo, water 2, yung pinangsaing mo. Overall, saan sila napunta doon sa sistema? We just look at all the input arrows na nanggaling sa out of nowhere and all the output arrows na papunta sa nowhere. So yung pinanghugas mo plus yung pinangsaing mo ay napunta sa wash water. Okay? Tinapon sa sink, naging steam, nag-evaporate, and then na-absorb ng rice. So we can actually compute for water based on this water balance equation. Then yung bigas naman, tinatawag natin siyang tie material or tie component kasi kung ano man yung mass nitong B, assuming na walang leaching out, 100% of that mass is in here. And then, kahit mag-evaporate yung steam, wala namang bigas na sumama dito. 100% of this mass is part of your cooked rice. Okay? So, again, in terms of solving mass balance problems, kasi the first thing you want to do is generate as many equations as possible and then correlate those equations to solve for your unknowns kasi may mga given ka naman usually. Okay, we have here the concept of boundaries. Hindi lang po ito yung interpersonal but in this case system boundaries, no? So whenever we produce our process flow diagrams or block diagrams, we conveniently use these dashed lines to indicate boundaries. And essentially, each box that you put here can result into one equation. So kung ano man yung tumatagos doon sa box na yon, papasok, yun yung left side ng equation mo. Kung ano yung lumalabas sa box na yun yung right side. And as many boxes as you can see here, so I have one equation here, one equation here, another equation here. No? So I use I use the boxes to visualize the process and write down my equations as well so that I can correlate them later on. So kung i-apply natin yung system boundaries dito sa pagsaing ng bigas, as you can see, there's an overall system boundary and overall mass balance there, yung black line. And then for each of the steps or processes, the washing and cooking, we have 2 boxes as well. So in this case, we can actually generate 3 equations. Again, for example, sa washing, on the left-hand side, you have B and W sub 1. Kasi sila yung papasok, and then on the other side we have W sub W wash water, and then yung B sub W or yung wet bigas. Okay, so parang ganun lang, no? For each box, that's how we write equations. And then actually this bigger box, yung equation yan would be the sum of the 2 smaller boxes, no? If you were to write them down and then add them up. So yaman din lamang na nag-discuss na tayo ng system boundaries ay dapat na rin siguro nating i-discuss kung ano yung mga systems. Okay, a system basically is an arbitrary region prescribed or nasa loob, pinapaloob na isang space or maybe a quantity of matter, and this system is separated from the environment by what you call the boundary, which is basically the dashed lines that you draw. And as you can see in these 2 illustrations from Singh and Heldman, the boundary may be stationary or movable, such as when the boundary is the system bounded is a gas which expands and contracts. So then essentially everything outside the boundary is called your surrounding. So you have systems and surroundings. Okay, another way of looking at it is kung yung mundo mo yung system, then everything outside your reach is your surroundings. So similar to what you've studied in Chem, systems can be closed systems, in which case there is energy transfer between across the boundary but mass cannot flow. So mahalaga itong assumption, no? Kasi kung magma-mass balance tayo, maigi na ma-define mo yung system at na-closed system siya. The energy transfer will be relevant once we do energy balance kasi later on hindi na lang mass yung titingnan natin pati yung energy flow kaya mas masakit sa ulo yon. Pero sa ngayon mag-enjoy muna tayo sa mass balance. So this is just an example of a closed system, the ecosphere. It's like a planet on its own, no? Pumapasok na sunlight, may isda dyan kung makita ninyo, or parang shrimp ba yan. And then may halaman, so magpaproduce ng oxygen, CO2, may cycle ka dyan, and may energy because of the sunlight. But I think that will eventually outgrow itself and die, parang ang mangyayari sa Earth pag na-overpopulate. Okay, a system could also be open, in each case both heat and mass transfer can flow. So typically when you do our mass balance problems, mga open systems ang dinideal natin kasi may mass flow. Kasi kung closed yan, edi wala ka ng arrow na papasok at palabas for mass, di ba? Okay, we also have adiabatic systems, which is either closed or open but without heat transfer, which is unrealistic. Even your vacuum flasks have some sort of heat transfer, albeit very slow rate. And isothermal, which is a system at a constant temperature, also somewhat unrealistic because temperature fluctuations are bound to be there regardless of whether you're using incubators or refrigerators. Of course, they're relatively constant, but not exactly isothermal. We have system properties are either extrinsic or intrinsic. So extrinsic or extensive is dependent on the size of the system, meaning its mass, volume, or length. Okay, so obviously, kapag mas marami kang nilagay dun sa process mo na mass of product or ng ingredients, mas malaki din yung extensive properties. Intrinsic properties, on the other hand, are those that do not depend on system size, such as density and temperature and pressure. So regardless if you have 1 liter of water or 10 liters, if it's 37 degrees Celsius, then it's 37 degrees Celsius. So I know you recognize equilibrium from your chemistry, but a system in our case is in equilibrium when all properties of a system do not change. So typically nandyan yung constant na yung flow niya ng input and output, constant na rin yung temperature ng system probably, okay? So isipin niyo to parang yung gripo, no? Pag binuksan mo yung gripo, bubulwak yan. Pag sinara mo yung gripo, hihina yan. Pero kapag halimbawa 2 seconds into after mo siyang buksan, steady yung flow niya, di ba? So parang ganun yung equilibrium. Okay? So we have what we call the steady state condition. It does not mean that the system is in equilibrium, but at the very least, the flow rate does not change with time. So parang yung sa gripo nga. Kasi pwede naman, for example, na constant yung flow rate mo, pero nagbabago yung temperature. Like for those of you na nakagamit na ng mga hot shower, di ba? Pag inon mo siya, mauunang maging steady yung rate ng pagpatak ng tubig. Pero yung mismong water, biglang iinit pa ng iinit. Okay, thermal equilibrium simply means that there is uniform temperature across the different areas in the system, as illustrated in here. And mechanical equilibrium is the same, but the system experiences uniform pressure, though we won't be assuming that much in our problems, no? Then we also have what we call phase and chemical equilibria, okay? And the definitions are also based on their main words to describe them. But I don't think this will be as important for our common mass balance problems at this point. And then we formally define a process as that thing which happens when your system undergoes a change of state. Now, in this case, the process is a change in temperature of the apple. So here's a short activity for you to do. In the next slide, there will be a link to a video. I can also include it in the study guide ninyo. You could watch the video and then on your own, pwede nyo i-pause, identify nyo una ano yung mga unit operations na nakita nyo doon. So basta diba meron kang input, process, and output, that would classify itself as a unit operation. And then isipin nyo kung based on visually what you can see, is it a batch process or a continuous process. Hint lang, typically pag may conveyor belts yan going in and out, usually ay continuous yon. Okay. and then you could identify the components that were used, and then you could construct a process flow diagram as well. Ngayon, para mas madali, since mas balance naman yung tinitignan natin, kapag sa tingin nyo walang involved na mass transfer, wag nyo na siyang isama sa sistema. Okay, so the answers actually are in the next part of this video lecture. So, i-pause nyo muna to at gawin nyo muna yung activity.